I'm pulling out all the stops on this one, right? We got a negative out front. That is a vertical reflection for those of you remembering your transformations. 4, that's a vertical stretch by 4. This is a decay function because it's 1/2 raised to the x. A number between 0 and 1 means that it's going to be a decay function. And we're going down 3. Fortunately, no left-right shifts, so that's cool. All right, what the heck is going on here? I'm thinking T-chart is the way to go, especially when you're a little bit shaky on these exponential functions or any graph, really. T-chart's the way to go. Now, before we were, choosing, got like 0 for an exponent, right? Usually like 1 and 2. With fractions, right, sometimes our negative exponents are helpful, but I'm also looking at that 4, right? If I have some fractions like 1/2 and 1/4 times 4, that's going to work out well. So why the heck not just go with it? All right, so I'm going to go with some 0. So I got 1/2 to the 0 power. 1/2 to the 0 power is 1. Times -4 is -4. Minus 3 is -7. And then if I raise it to the first power, that's 1/2. But that's okay because I'm going to multiply it by -4. 1/2 times -4 is -2. -2 minus 3 is -5. If I square that, it's 1/4. But again, no big deal because I'm multiplying it by -4. So that gives me -1 minus 3 is -4. These are all pretty easy numbers to work with, right? All pretty easy numbers to work with. So let's go ahead and start plotting these. If we need some more, we'll get some more. So I've got 0, -7, and that goes all the way down to, I think, right about here. No, wait, that's 6. So there's 7. All right. And then I got 1, -5, and I've got 2, -4. Okay. There we go. So I got 3 points. I can kind of see a little bit of a curve. Right? I can see a little bit of a curve. What about my asymptote? Where the heck's that going to be? Well, if we shift the graph down 3, the asymptote moves with it. So let's pop up that ruler. Oh, it's almost perfect. And it's going to be right here. Right at -3. Okay. And that's y equals -3. That's my asymptote. So I think now we can kind of see what the heck's going to be going on here. But just in case, if we were to plug in, say, one more point, let's go with plugging in 3. I'm going to have, let's see here, that's going to be 1/8 times -4. Maybe we want to jot this one down. -4 times 1/8 minus 3. So that's going to be -1/2 minus 3. That's -3.5 or -3.5. All right, so we're going to be sitting right here, and I think now we can see what's happening here. We've got, I kind of want to try that one again. Let's try that one again. That works. That works. All right. So this thing, it does actually match with what we were thinking, right? Because an exponential decay function would look like this normally, right? So it is reflected, right? It is reflected. Okay, if one was shifted and all that stuff like we just did. So that looks, makes sense, okay? Our asymptote shifted. What's our domain and range going to look like, though? Because this seems like it could change here. Well, my domain, again, it continues going to the left, continues going to the right. So x is still going to be all real numbers, and that's always going to be the case with exponentials if you have not yet figured out. So -infinity to infinity would be my other option. But how about my range? Well, my range is about how low or how high we can go, right? My y values. Well, this thing can keep going down, right? But it stops at just before -3. Never gets to -3. So it would be y is less than -3. Or we can go from -infinity. My infinities aren't on point here. That's a little better. -infinity all the way to -3. I think that's all awesome. That's fantastic. All right. We handled it. T-chart, anytime you're not sure. Always good to plot some points. T-charts are your friend. Isn't that right, Jenny? T-charts are our friend? Yes, they are. Yes, they are. All right, you guys have a wonderful day. America, freedom, rock and roll, Costco. Riverdog Jenny on the gram. Yo-ro, you only round once. You guys have a great day.